Hello everyone. So today in this video I'll discuss about the superposition of wave. So when two waves will mix together, then what will be the resultant amplitude we'll calculate, what will be the resultant frequency, all these things we'll discuss in this video. So let us say one wave is traveling like this, another wave of similar amplitude is also traveling like this. Then what will be the resultant wave? Means these two waves, they overlap each other. So what will be the resultant? So resultant is, let's say this is the resultant, which is having higher peak. That means its amplitude is increasing because two waves, they are mixing and you are getting a higher amplitude. Now mathematically let's try to understand this. This is, let's say, displacement. This is your time. This is your propagation, right? In x direction. So now let us mathematically try to analyze it. Let's two waves are here. Let's say one wave I'll write y is a function of your x and t, and it will be like a sine kx minus omega t. With this form we can write the one wave, that is, let's say y1 we can write. So y1 is having amplitude a, and this is your oscillating one, sine kx minus omega t. It is progressing in x direction, so we can say its kx will come. If it is propagating in y direction, you can write ky also, right? And omega is the angular frequency, the frequency of this wave. Now y2 will say they is also having same amplitude. It is also a function of x and t, and amplitude also, for simplification, will write, I'm writing also having same amplitude. You can write a1 a2, and the calculation also possible. A little bit lengthy mathematics will be. So we have taken the simple case, and this is your sine kx minus omega t plus phi. Phi is the phase angle I have taken, and initial phase difference between the two waves. Let's say the wave starts from here, another wave starts from here. So this is your phase difference. It starts from here, another wave starts from here. So initial phase difference, if they are starting from same point, phase difference is 0, right? If they are in phase or phase difference is 0, then if the phase difference is 0, then we can say that is in phase. If the phase difference is pi, then we can say it's out of phase. Suppose one wave is moving like this, another wave will exactly opposite like this, so we can say it's out of phase. The phase difference is pi. So here we have taken a phase difference. This two wave, everything is same, only pi is extra. That means the wave, both the waves are differed by only a phase difference pi. Now what we are doing, we are adding these two waves. We are adding the displacement, and we'll get the net displacement of the wave, of the red one, you can say. So y will become y1 plus y2, and y1 is a, both a is there, I can take a common. So sine kx minus omega t plus sine kx minus omega t plus phi, right? Now we can use a sine a plus sine b formula, right? So you know in your trigonometric that sine a plus sine b is 2 sine a plus b by 2 into cos a minus b by 2. So this is the formula. In mathematics you should know this formula. In your trigonometry class you might have learned. So here we'll use this quantity, we can imagine as a, and this whole quantity you can imagine as b. Now you can use the formula. So what you will get, the net displacement is also will be a function of x and t. This one you can You may write, you may not write, just to understand that this is a function of x and t. Other quantities are constant, and that's why x and t inside the bracket, it's nothing multiplied, it's just a function of x and t. So y is equal to a, and this is your, you can use a plus b, so kx minus omega t, kx minus omega t. So 2 times will come, 2 times kx minus omega t, and plus phi is there, right, by 2, a plus b by 2. Look at the formula, right? Sin a plus sin b equal to 2 sin a plus b by 2 cos a minus b by 2, and multiplied cos a minus b. So this one minus this one, so kx minus omega t cancelled out, and minus 5, so minus pi by 2. Fine. Now I can write in a simple way that y equal to, this is the result, means red one. When we are adding these two waves, we are getting the resultant wave. This is your final result y, we are getting the displacement, and this is the displacement we are getting, and the height, maximum height is amplitude. So y is it's 2, so 2 times it's there, so 2a, this will be 2 to cancel out, it's 5 by 2, so it will be sin kx minus omega t plus 5 by 2. Cos minus 5 by 2 is cos 5 by 2, because you know the cos theta is, cos minus theta is cos theta. Cos is an even function. Also from this ASTC form rule also, you know that cos minus theta, this is, let's say, minus theta, this quadrant, this is all positive, sine positive, t, this is cos and sec positive, so this quadrant, say your cos positive, so cos minus theta will become positive, so it will be cos minus theta is cos theta, remember. So this is cos is a even function, cos minus theta is cos theta, sin theta minus theta is minus sin theta. You remember this. Mathematics students, you know all these things. Those who are not having mathematics, you should know a little bit of trigonometric to solve the questions. So I can write simply, this is cos 5 by 2, or I can write this cos 5 by 2 here. I can write this is 2a cos 5 by 2. So now this, say here cos 5 by 2 and 2a is a constant. So this will be a combined amplitude, and this one is the oscillating part, sin kx minus omega t. So the result wave also will oscillate with same frequency. You see, we have taken omega here as a single wave, the frequency of the single wave, but also the resultant wave also coming out with omega. That means resultant wave also will oscillate with same frequency omega, and resultant wave phase will be differed by 5 by 2. Now what about the amplitude? Amplitude is your 2a cos 5 by 2. Alright, now from here we can get some idea about your interference that you will learn in light chapter, that when two waves interfere with each other, we get some fringes, dark and darkness and bright, dark bright fringes we get. So these fringes, what we get, this darkness and brightness are called, brightness is the your constructive interference, due to the constructive interference, and darkness is due to the destructive interference. Fine. So here in case of constructive interference, the brightness will get the maximum amplitude of this resultant wave. So to get the maximum amplitude of the resultant wave, our this part 2a cos 5 by 2 should be maximum. So when cos 5 by 2 is maximum, cos pi by 2 is maximum when cos 0, that means 5 by 2 must be 0, because cos 0 is 1, so it's maximum. cos function value are 0, 1 to -1. The maximum value is 1. So pi by 2 will become 1 for theta equal to 0. Theta is here pi by 2. So amplitude maximum you will get for phi by 2 equal to 0, or you can say phi equal to 0. So for phi equal to 0 degree, your phase difference is 0, then you will get the maximum amplitude, that you will get your y equal to 2a sin kx minus omega t plus phi by 2. So this is what you will get, the maximum for the maximum amplitude, the displacement for the maximum amplitude, and it will be basically, the amplitude will be 2 times of initial amplitude of the wave, because we have taken amplitude A for the individual wave. So the resultant for maximum amplitude, resultant is 2 times of the twice of the individual amplitude. Now where you will get the destructive, so this is the case for constructive interference or brightness. So when two waves interfere, you get dark bright, this type of fringes you get. In light chapter in detail we will discuss, we will calculate the fringe width. So here brightness you will get because amplitude is maximum, higher amplitude you are getting. Now let's say two waves, they are interacting like this. One wave is this, another wave is this. Then the result will, the amplitude will vanish because they are in opposite phase, right? So their amplitude will vanish and you will get a darkness. Let's say this is your darkness, then bright, then darkness, then bright, right? So darkness, how will you get? When the two waves amplitude will cancel each other, and that will happen when the phase difference is, your phi will become pi. Your phi will become pi, or you can say, so when your phi becomes pi, phase difference is pi, then the destructive interference will occur, and for that cos phi by 2 will become cos pi by 2. Cos pi by 2 is 0, and you will get y equal to 0. That means your displacement is 0, amplitude will become 0. So 0 amplitude, you will get darkness, so and displacement also 0. So for phi equal to